So if we think about the equation that we were doing before, which was, the sum of all these gammas times some R max, we can basically take out the R max, and what we end up with is something that looks like that, right? You're summing together a bunch of gammas and then multiplying the result by R max. So what does that actually look like? Well, that looks like this. Gamma to the 0 plus gamma to the 1 plus gamma squared plus dot, 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 eventually multiplied by R max, right?
Mm-hmm.
So let's call this X, okay?
Does X include the R max or not?
No. So we'll just call the little sequence of it's going to turn out not to matter, but let's just call the sequence of gammas that we're adding together, let's just call that X.
Good.
Well, if you look at it, this is actually recursive, right? Because it's an infinite sequence, if you sort of shifted it 1 over in time, you would end up with just the repeated sequence again, right? Which means that we can write X in terms of itself. X equals gamma 0 plus gamma times X.
I see. So it's shifted over, but then you have to multiply it again by gamma to get up to gamma 1, gamma 2.
Right, exactly. So this is just, it's just math. That's just all it is. So we can try to solve for X and figure out what X is, right?
Cool.
So what is X? Well, we can subtract from both sides, and so we end up with something like X minus gamma X equals gamma 0, right?
Seems like we can stop writing gamma 0. Isn't that just 1?
Yes, but I've gone too far, Michael. I've already
All
written
right.
gamma 0. So this becomes X times 1 minus gamma equals gamma 0, or as Michael so astutely points out, 1, right? Which means what? It means that
So then we divide by 1 minus gamma.
X is 1 over 1 minus gamma.
Neat.
And that, of course, we're going to multiply by R max.
And get the formula that we had. That's nifty.
Yeah, and there we go. So why do we do this? Well, because you like stuff like this. And it points out something very simple, which is that geometry is easy.
I don't think that's the kind of geometry that people usually think of.
Well, they should be thinking of this kind of geometry. So geometry is easy. And by doing little cute algebra, we can derive ridiculous equations that turn out to help us go an infinite distance in finite time.
I don't think that's what they're doing, but okay.
So let's think of this as warm-up for what I actually wanted to show you, which is going to turn out to be a whole lot of math. Okay?
All right, let's go for
All
it.
right, let's do that.